Dear student, this is our first lecture of quantum mechanics, and we are going to discuss some key ideas or some main features of the quantum mechanics. As you know that the quantum mechanics is almost about 100 years old, and it's taught with the Max Planck and Einstein ideas about the light. Quantum physics has replaced the classical physics as a correct fundamental description of our physical universe. It is used routinely to describe the many physical phenomena, and so you can say that the quantum physics is a result of applying a framework of quantum mechanics to the different physical phenomena. Like you can say that when quantum mechanics is applied, when we apply the quantum mechanics to the electromagnetic theory, then as a result we have quantum electrodynamics. Quantum electrodynamics. And in the same way, when we apply the quantum mechanics to the optical devices and light, okay, that is when we apply the quantum mechanical phenomena or quantum theories to all the phenomena that related to the light and optical devices. As a result, we have there is a field of quantum optics. And in the same way, when we apply the quantum theory to the gravitational field, okay, then we apply the quantum theory to the gravitational field, then we have quantum gravity. Quantum gravity. So we can say that the quantum physics is the result of applying a framework of quantum mechanics to the different physical phenomena. The era of the quantum mechanics began in 1925 with the discovery of Heisenberg and Schrödinger. So, the seeds of these discoveries were planted by the Planck, Einsteins, Bohr, de Broglie, and others. So, in this lecture, I am going to explain some main key features of the quantum theory, and we will discuss that actually what kind of theory this quantum mechanics is. So, the main feature of the quantum mechanics which we are going to discuss in this lecture are: number one, we will discuss linearity. Okay, linearity. And linearity will tell us that that this properties tells us that what kind of theory the quantum mechanics is, and how we can argue about this theory. And secondly, we will discuss about the quantum mechanics, that how the quantum mechanics is indeterministic. Okay, the quantum mechanics is not deterministic. In contrast to the classical physics, the results of some experiments cannot be predicted like in the classical physics. Quantum mechanics is a framework in which we always predict the thing. We can predict any probabilities for the various outcomes of any experiment. Okay. Thirdly, we will discuss about the quantum superposition. Okay. Quantum superposition. And fourthly, we will discuss about complex number. Complex numbers. That how the complex numbers are the necessary part of the quantum mechanics. So first, we are going to discuss about the linearity. In order to discuss the linearity in quantum mechanics, first we will discuss about the linearity of the equation of motion. linearity of equation of motion. So in physics, we describe the theory by some set of equations. So in order to describe theory, what we need a set of equations. And you know that and equations always have some quantities and always have some variables which are called as dynamical variables of the theory. Dynamical variables of the theory. So in order to describe any phenomena in physics, we need theory, and theory has some set of equations, and in order to solve the equation, we have some other quantities which can be represented by some dynamical variables, and these are the dynamical variables of theory. So in physics, after writing the theory, the most important thing is to find out the solution of equation. So when we find the solution of equation, then we can describe the different possibilities. So let us suppose that expanding the universe, expanding of universe. Expanding of universe is the solution of Albert Einstein theory of gravitation. So gravitational and in theory of gravitation we have the equation. So the solution of that equation tells us that the universe is expanding. So in quantum mechanics we have the two types of the theories. Some theories are the linear and there are some non-linear theories as well. So we can say that there are linears and non-linear theories. And there are linear and non-linear theories. So all theories are not linear, neither all are non-linear. Some theories are linear and some theories are non-linear. And here we are going to discuss that which type of theories are linear and which are non-linear. So the non-linear theories are more complex. Non-linear theories are more complex. So these are the more complex, then it is more difficult to find out the solution of non-linear theories as compared to the linear theory. Linear theories are simple, and so we can easily explain the linear theories. And the most remarkable thing about the linear theory, why the linear theories are simple. The most remarkable thing about the linear theory is that the linear theories are in the linear theory we can find out the solution and we can add the solution. We can add the solution to find out, we can add the two solution to find out the third solution. So we can add up the any number of the solution in the case of linear theory, which is not possible in the case of non-linear theory. So we can say that the non-linear theories are the more complex. We cannot easily solve the non-linear theory as compared to the linear theory. We can easily solve, we can easily find the different solutions in the case of linear theory. Here we will discuss an example of linear theory as a theory of Maxwell theory of electromagnetism. So first here we will take an example of Maxwell theory of electromagnetism. So you know that about the Maxwell theory of electromagnetism that usually discuss the behavior of electric and magnetic field. That is, here we will discuss about the electric and magnetic field. A field, usually know that field is a quantity and that depends on that probably depends on the position and the time. It depends on the position and time. So here the simple solution of this Maxwell theory of electromagnetism is the electromagnetic wave. Okay, we have the electromagnetic wave, which is the simple solution of Maxwell theory of electromagnetism. So this wave can propagate in one direction and it also can propagate in some other direction independent of first direction. As the Maxwell theory of electromagnetism, Maxwell theory of electromagnetism. Electromagnetism, we say that it is the linear theory. Okay, it is a linear theory and its simple solution is the electromagnetic wave that is propagating in the specific direction. So the Maxwell theory, we see that it is a linear, so linear theory, so it can have the two waves propagating simultaneously, two propagating waves simultaneously in different direction. Okay, in different direction. Okay, so each one is the propagating in its own direction without affecting the other one. So sum of these two solutions will also be the solution, as we already know that this theory is the linear theory. So the solution of these two waves, solution of these two waves, which are the solution of electromagnetic theory, these two waves is also solution, is also another solution. That is when we have one wave propagating in one direction and another wave propagating in another direction and third one also propagating in its own way. All waves are propagating in their own way without affecting each other. So all these electromagnetic waves are the solution of Maxwell theory of electromagnetism. So here we take the two waves. Okay, first electromagnetic wave and second electromagnetic wave. So when we add up these two electromagnetic waves, when we take these two waves, electromagnetic wave, we get another electromagnetic wave, which is also solution of electromagnetic Maxwell theory of electromagnetism. So in the in the resultant wave, the electric field component of first wave and the second wave add up to give the electric field of resultant wave, and similarly the magnetic field component of first wave and the second wave combine to form the magnetic field component of resultant wave. So we get the resultant wave, which is also solution of the Maxwell theory of electromagnetism. So in fact we can add any number of the solution and still we can find another solution. So this is the beauty of linearity. So whenever the equation is linear, it is very easy to add up two solutions to get another solution. We can add any number of the solution to get another solution. So this is the beauty of linearity, property of the linearity. And as you know that The air around you is full of electromagnetic waves, each one propagating obvious to the other one, and so there are the waves of thousands of the cell phone, the waves carrying the hundred of internet messages, and wave from the radio stations, TV stations, and there are many more. So we can say that simple optical fiber or simple transatlantic fibers can carry simultaneously millions of the telephone calls, and it can together with a lot of huge data of the videos and internet data. So all of that is the courtesy of the linearity. You can say this is possible because of the linearity. So, the solution of Maxwell equations can be described by electric field. We can describe it by the electric field E, and magnetic field B, and then we have the charge density rho, and we have current density J. So this set of variables, that is electric field B, rho, and J. So this is the collection of field and sources that defines the Maxwell theory. So all these are the basic fields and sources of Maxwell theory of electromagnetism. So if this is the solution of this is the solution to electromagnetism or Maxwell theory of electromagnetism, then alpha E, alpha B, alpha rho, and alpha J should also be the solution to the Maxwell theory according to the property of linearity. So for simplicity here we take only the two solutions like E1, B1, rho 1, and J1. If let's suppose this is the first solution, and E2, B2, rho 2, and J2, this is another solution. So if these two are the solution, so by adding these two solutions we get E1 plus E2, B1 plus B2, rho 1 plus rho 2, and J1 plus J2. So this will also be the solution. So this is the solution, this one is the solution, then this one, which is the combination of first and second solution, will also be the solution. These new solutions can also be called as the superposition of first and 1 and 2 solution. So this is the superposition of two solution. Okay,